We got delta U for the reaction. The next thing we need to do is calculate delta H. Okay? So remember, enthalpy is U plus PV. So delta H is delta U plus delta PV. Now, your volume is fixed, right? This is a constant volume calorimeter. So if you have P final, V final minus P initial, V initial, if volume is fixed, okay, then that's just P final minus P initial times the volume. So that's V delta P. Or it's even easier if you just say, okay, we're really interested in uh, delta N RT here because PV, okay, delta PV is basically going to be delta of nRT. Why? We're assuming ideal gas behavior here. Okay. So let's calculate delta N gas. Oh, first of all, we need to calculate delta H combustion per mole. Let's write the balance equation first. Okay. So let's go ahead and do that. What's our balance equation? What's the formula of my stearic acid? My stearic acid is C18. Stearic acid is C18H36O2. Okay? C18H36O2 solid plus O2 gas. That's what happens in combustion. What are the products of combustion? CO2. Lots of oxygen. So all of your carbon ends up as carbon dioxide. What happens to all the hydrogens? Become water, liquid, 25 degrees eventually, and that's it, right? So how do I balance this equation? I want to use 1 mole there. I have to fix that. So how many CO2s do I get? 18. How many waters do I get? 36 hydrogens. So 18 water. You're gonna have a different balance equation for your own unknown, right? This is for stearic acid. How many oxygen should I have? On the right side, oxygen is 18 times 2 plus 18. That's how much? 36 plus 18. That's 4, carry 1, 54 oxygens on the right. How many oxygens do I have on the left? 2 over here. So how many oxygens do I need here? 52 divided by 2. So I need 26 O2. Okay, so that's my balance equation. 26 oxygens, 18 carbon dioxides, and 18 water. So I would write that over here. So C, what was it? 18H36O2 solid plus, how many O2s did I say? 26O2. 26O2 gas, right arrow, 18CO2 gas plus 18H2O liquid. So what's the change in moles of gas here? Delta N gas is, how many moles of gas on the product side? 18 CO2s minus 26 O2s on the left side. So 18 minus 26 is how much? -8. Okay. So iron delta N gas is -8. So I actually write a formula here. I'm going to have 18 CO2s minus 26 O2s. So negative 8. Mean temperature of the unknown run. This is where the mean temperature comes in. Okay. So if you look at your chart, okay, what's my mean temperature for this unknown run? Approximately right here. It's around maybe 27 degrees. I'll just assume it's 27 degrees, but you read that off your chart. So I'm going to say 27 degrees. So plus 27 plus 273.15 Kelvin. So 300 Kelvin is my mean temperature. So how do I calculate delta H? Delta H is delta U plus delta N gas times RT. Okay? So that's your delta H. So delta U plus delta N gas times RT. So this is going to be equal to delta U plus delta N gas times R. What's my R? I want my R in kilojoules, okay? So R is 8.314 joules per mole Kelvin. That's 8.314 times 10 to the negative 3 kilojoules per mole Kelvin, okay? Don't forget that one. Because my answer needs to be in kilojoules. So this is going to be, I have delta U plus delta N gas times R, 8.314 E minus 3, okay? Times my temperature, which is Kelvin right here, right there. So it's 0.008314 is your R. So that's negative 11,307. My temperature is this one right here. My average temperature. Where do you get your average temperature? Right here where the line crosses, your mean temperature. That's why you have to determine that, especially for the unknown run. Okay? So my T initial is 24.39, my T final is 28. My mean temperature is around 27 point something. I'm just going to use 27, so that's 300 Kelvin. Yeah, you have to do it precisely as you can. That's why you have to do your graph on Excel. Okay. I'm just giving you the numbers here to give you an overview of what's involved. So you got a lot of work to do after this for your own data. But at least you've been through the process of doing it. All you have to do is replace the numbers that I put in here. Okay? All right, so our sample is CXHYOZ. What's our X? In this case, I have C18. So 18. My Y is 36, right? And my Z is 2 oxygens, right? C18, H36O2. Why am I interested in that? First of all, how do I get the delta H formation of CO2 gas? I can look it up. In fact, your unknown, your handout tells you that number. What is it? Minus 393.51. Kilojoules per mole. This is for CO2. Okay. You can look it up from an NIST webbook. So you go to webbook.nist.gov. Look for CO2 gas, formula CO2 gas phase. search. And you can see right here, delta H formation of carbon dioxide is negative 393.51. Okay, so I'll enter that over here, minus 393.51. What is it for water? Someone look it up for me. You're going to have to look it up and take a screenshot. What's the value for water? Liquid water. Okay, so you go to webbook.nist.gov, click on chemistry webbook, click on formula, enter the formula what you're looking for, H2O, and then you're looking for condensed phase for the water, liquid water. So do a search, and here it is for liquid water. Okay, so let's do a snip of that. Okay, copy, paste that to your Excel document. Okay, so that's liquid water. What is it? Minus 285.830.
How are you able to find the liquid? It's only one of gas for me in the liquid.
When I did my search, I checked condensed phase. Paste the screenshot. Yeah.
Only for water, or do you need carbon dioxide?
What does the handout say? Well, the handout already gives you the CO2 anyway. So. All right. I'm sorry. This one doesn't say. But if you want, you can put the reference link there. I'll know if it's water based on the numbers. If you want to remind yourself where you got it from, you can put the link. Okay. So it's minus 285.83. This information right here, along with the delta H of combustion, will let you get the delta H formation of your sample. Okay, why is that? Well, let's see. Let's do it again. So, in general, if I have X, CX, HYOZ, okay, and I react that with oxygen, what are my products for combustion? How many moles of CO2 would I get? If I have X moles, X carbons in my compound, I'm going to get X moles of CO2, right? What's my other product? Water. If I have Y moles, Y hydrogen atoms in one molecule of my compound, how many water molecules will I get? What's the coefficient here? If this equation were to be balanced, y over 2, because there's 2 over here. So if I multiply y over 2 by 2, I get y. Okay? So this is balancing the algebra. If I have, how many oxygens do I have on the right now? I have 2x, right? From the carbon dioxide. Plus, how many oxygens from the water? 1 times y over 2, right? So my oxygen on the right is 2x plus y over 2. How many oxygens do I have on the left? That's Z plus, what's my coefficient going to be here? Let's call this W. Okay. What would that be? Z plus 2 times W, right? These two should be equal. Same number of hydrogens. All right. Now, why is it important for us to know this? So I can solve for W here. If I wanted to solve for W, my W is going to be equal to what? 2x plus y over 2 divided by z. Minus z. Y over 2 minus z divided by 2. Okay, so that's my W. That's the W that goes there, right? The point is this. If I know the delta H for this reaction, what do you call the delta H of this reaction? The enthalpy of combustion, right? So I'm going to say, okay, the delta H for this reaction is the delta H of combustion. And that's just the delta H formation of the products minus delta H formation of the reactants. So I know this from experiment, right? That's what we just calculated. Delta H combustion of per mole of my stearic acid. We just calculated that. So I wanted to know, if I know the delta H combustion of stearic acid, can I figure out the delta H formation? Well, let's look at our equation right here. What's our delta H of this reaction? Let me take this out. Delta H of this reaction, which is the delta H of combustion, I'm just going to say delta H sub C there, or I can put COMB, is equal to X times delta H formation of CO2 per mole times X moles of CO2 plus Y over 2 times delta H formation of water. Okay, so this is delta H formation of the products. I'm going to put a W there. Okay, so I got products minus delta H formation of reactants, which is CXHYOZ plus, what's the delta H formation of O2? W times 0, okay? O2 gas is an element in its standard state, so that's just going to be 0. So this is just going to be 0. So if I know delta H combustion, I look up delta H formation of CO2. I look up delta H formation of water. What's the only unknown in this equation? This is from my experiment, delta H combustion. Delta H formation of CO2, I can look that up. I did look it up. Delta H formation of water, I looked it up. I know my X and my Y because I know my compound. I know my X and my Y. So the only unknown here is delta H formation of my compound. Okay? So how would I solve for that? That's simple. I just rearrange this. I can just say delta H formation of CXHYOZ is equal to X times delta H formation of CO2 minus plus Y over 2 times delta H formation of water minus my experimental delta H of combustion. And so that's the formula you would have to enter in your Excel sheet. Okay? So that goes over here. So what was our formula? Equals delta H combustion per mole of sample minus, or no, equals x, which is this one, times what's the value for water? For CO2, that one, plus y over 2, that divided by 2 times the value for water, right? If that bothers you, you can put this in parentheses, y over 2 times the value for water, okay? Minus the delta H combustion of, what was it? Minus the delta H combustion, right? Right there. I don't need this extra parenthesis actually. So it's minus 920. So for stearic acid, apparently based on my data, the delta H of formation is minus 920 kilojoules per mole. So what do I need to do now? I go to look for stearic acid from webbook. So I search for name. I search for the name. That way I don't have to type the formula in because there may be several compounds that have the same formula. Stearic acid, condensed phase. I can do reaction too if you want. And there's stearic acid. Okay, C18H36O2, also known as octadecanoic acid. Octadeca means 18 carbons, right? And it's a carboxylic acid. Yes. Stearic acid. Benzyl. Okay, we'll look for it in a little while. Okay. So now that you have this, I've got my value. Ooh, I've got a good accuracy here. So what I need to do is I copy this link, put my link over here for my literature value. And my actual literature value, I'm going to take a snip. I'm going to go take a snip of my literature value. Delta H formation is actually a liquid. Okay. Delta H formation, edit copy. I can put it in my Excel, put it somewhere over here. It's minus 891 kilojoules per mole, plus or minus 2. If you look at the delta H combustion values, 11,200. That's pretty close. I've got 11,300. Okay, so I can calculate my percent error. So this is the screenshot of my literature value. All right. So that allows you to determine the delta H of formation of your compound from combustion data. And that's what you need to do. You found it? Okay. Huh? Take a snip of the literature value. Which one? Delta H formation? Yes. Okay, so that's X times delta H formation of CO2 plus Y over 2 times delta H formation of water minus the delta H of combustion. All right, so that's what you need to do. Pretty accurate given that I didn't even try to accurately. Of course, this is a simulation. So. I'm sorry, D42? This one? That's the water. That's minus 285.383. That's the literature value for water, liquid water.
What are we looking for again?
The delta H of formation of your unknown.
Oh, that's for the unknown.
Wait, -285 is for water?
Yes.
So I just have -285 there as well.
And for CO2, it's given in your handout. It's negative 393.51.
Okay.
Okay?
And then where do you get your standard delta H4 formation of samples per mole?
Calculate that from this formula right here. Delta H of combustion is X, delta H formation of X moles of CO2 plus delta H formation of Y over 2 moles of water minus delta H formation of your unknown. Since you measure the delta H combustion in your experiment, you can solve for the delta H formation of your unknown.
So where do we solve for that?
So down here, I just rearranged this equation in blue. I have the equation in red. Delta H formation of my unknown is X times delta H formation of CO2 plus Y over 2 times delta H formation of water minus delta H of combustion.
Which is what we put.
In your Excel sheet right here,
Okay.
this is equal to X, this B38 times delta H formation of CO2, which is B41, plus Y over 2, which is B39 over 2, times delta H formation of water, which is B42, minus the delta H of combustion.
Okay.
Okay? And the rest of this you should be able to figure out on your own.
Well, whenever you went to NIST and you looked up the condensed phase chemistry data,
Uh-huh.
mine saying it's a solid.
Solid? Yeah. Then that means your compound must have been a solid.
You just read the first value for delta T of formation.
Yeah. That, actually, there's two values here.
Not for water. I'm talking about for your unknown.
Oh, I only have one number.
Oh. So if I
My
have,
stearic acid is a liquid. It's an oil.
so I have three.
Okay, just pick one.
They're different.
How different? Different.
Like -154, -179, and then 138.
Okay. You can pick one or you can take the average of the three. I mean, those are all reliable sources apparently. So for them to make it to that table. Yes. Yeah, for your you can do that. I don't have to show you how to do that, right? Huh? 11%. My percent error would be this one minus that one divided by that one times 100. 3% error.
Wait, this can't be correct.
Huh? No, I have percent error for the delta H formation. Okay? Yes. Okay, hold up. Let me stop this recording because I'm pretty much done here with the